This is TechMath 2. Maybe it is. That's better. And this is the last section of TechMath 2. We're in 14.4. This is the last time we cover any new material. The next 2 days we're doing review for the final, which will be a glorious event. So the issue is I'm going to take some imaginary number and raise it to some power, or I'm going to take the root of some imaginary number, whatever it might be. How am I going to do that? Well, if I am in exponential form, e to the j theta, and I'm raising that to some power of n, then that's going to be r to the n ej to the n theta. And that's how I'm going to do that. And if that happens to be e to the j theta happens to be a 1/2, then I'm going to do the same thing. I'm going to go r to the 1/2, the square root of r, e to the j n theta 1/2 theta. And then I'm going to worry, because in this particular case I'm going to go around the unit circle more than once, so I'm going to have to go find the other guys. I could also be in polar form, so I could have r angle theta, and I'm raising that to the n. Well, that'd be the same thing, r to the n angle n theta. So I could do the same thing. If I had b plus beta I, and I raised it to the n power, or I had b plus beta I, and I took the nth root of it, then I'm totally hosed. I can't do that easily, and so I'd want to put it in either polar form or exponential form in order to do the work to begin with. So with it in polar form or exponential form, it's easy to find a power of a root. But if I had 1 plus 2i raised to the 5th power, then that would be a pain in the backside to try to do that manually. I'd end up having to come up with Pascal's triangle down to the 5th guy, and then I'd have 1 to the 5th plus 1 to the 4th, 2i to the 1st times 5 plus 10 times 1 cubed 2i squared plus 10 1 squared 2i cubed plus 5 times 1 times 2i to the 4th plus 2i to the 5th. So I could do it, but that would be not something that I'd want to do, because there's easier ways to do it. Now, if I'm taking a square root of guys, so on page 492, we see that if I'm r angle theta and I want to take the nth root, then I'm going to have to go with r to the 1 over n, and then I'd have to go with theta plus k times 360 divided by n as my angle, and then I'd have to go and go around the unit circle many times. So then k would be equal to 0, and then be equal to 1, and then 2, and it'd go all the way out to n. So I'd have nth roots of r angle theta. Now, it's written slightly different there on the page 492, but that's really what it's saying. Okay, and with that, we've covered all the theory, so I guess we'll just do problem number 1. Hope for the best. 3 e to the 1.4j raised to the 5th power. Now, 3 raised to the 5th power, that's 243 maybe? 243e, and then 1.4 times 5 would be 7j, right? And then I take out my calculator and make sure that I didn't do that too poorly. So 3 raised to the 5th power. Oh, look at that. That's a lucky guess. 1.5 times 5. And yeah, that'd be good. So that's all there is. There isn't much more than that. We'll do it again for number 3. Now, next semester in the fall, we're doing Tech Math 3. In Tech Math 3, what happens is I work even problems. The homework are all odd. So this semester, I got to work the homework problems that you got to do. Next semester, you get to work different homework problems. So if you want to, you could, over the summer, work all the homework problems from chapter 14 on to around 23 or so you'd be prepared. Oh, okay, well, you're not going to do that. Okay. Yeah, no one's ever done that, so don't worry about it. 5 e to the 4.6j squared. I said it'd be 5 squared, 25 e to the 4.6 times 2, 9.2j. Okay, we'll move on to number 5. Now the reason I do only the even problems in Tech Math 3 is because there's no answers in the back of the book for you guys to check, so you don't know if I get them wrong. 3 cosine 20 plus j sine 20 raised to the 4th power. Well, that's better. 3 to the 4th power is 81, so that would be 81 cosine 180. 4 times 20 is 80. Plus j sine 80. All right, well, let's look at number 8. That'd be good. Number 8. We have 5 angle 275 degrees, and we're going to go cubed. Okay, so 5 cubed 125. And 3 times 270. 270 times 3, 825. Well, we wouldn't leave it at 825. We'd subtract 360 from it. And then we subtract another 360 from it. And we call it 105. So 835, 1, 2, 3, that'd be 835. But that's the same as 105, so we would leave it at 105 is what we would do. Well, 10 looks different. I guess we'll do 10. And because it's different, we'll have to change the color of our pencil here, our pen. 1 cosine 220 plus j sine 220 to the minus 4. To the minus 4. All right, well, 1 to the minus 4 is just 1. And so that'd be, so I wouldn't have to write it down. I'll write it down. And then 220 times minus 4 is minus 880. So that'd be cosine minus 880 plus j sine minus 880. All right, and then we'd go and say, well, I better add 360 to that. Add 360, add another 360, add another 360. Wow, 200. So that'd be 1 times cosine 200 degrees plus j sine 200 degrees. Now, if we looked at that differently, so we're going to do it one more time, and we're going to look at it differently. Okay, what's the question?
Couldn't you take the 220 times the cosine, or cosine 2 times 220 degrees, and just sine times 220 is 42 times -4?
But this is a plus sign here,
Right.
so I'm not multiplying anything there.
Well, no, I wasn't saying multiply there. Do your cosine of your 220, figure out that one, and then your sine of your 220, and then take both sides times the -4 once you already know the sine.
But you could, but that's not what they're asking to do, I don't think, because they want the results in trigonometric form. So if they said put the results in rectangular form like we do in problem 11, then yes, you would do that. But they're not telling you to do that. In this particular case, if you were to 220, that's be the cosine of 40. If you went and said the cosine of 220 is minus 0.766, and you raise that to the -4th power, you would end up with the wrong answer. So that's the issue. No, you can't do that. That would be violating the rule of you have to do what's inside the parentheses before you can take the power. So it's an order of operation thing. So no, you can't do that. Now if I rewrote this as 1 angle 220 to the -4 power. Let's say I did that. And I said, well, that's 1 over 1 angle 220 to the 4th power. I could do that, right? And then I could say that's 1 over 1 angle 880. And then I could say that's 1 angle minus 880. And then I'd do the same thing, and I'd still get 1 angle 200. So I could do that if you wanted me to do that. But what you wanted to do, you can't do. That's sort of like saying I got 1 plus 3 to the 1/4. That's the same as 1 to the 1/4 plus 3 to the 1/4. That's not going to work. Can't do that. Okay. All right, we're going to do number 11 next. Oh, there's always good ways to get it wrong. I mean, there's no doubt about that. Let's go back to the same problem and see what my calculator, and we're going to go back to 10 again. And we're going to take the calculator and go parentheses cosine 220 plus I times sine 220 raised to the -4th power. And it gives us the domain error. It's not going to even do that for us. But if I go and take, I'll put parentheses, 1 second function complex angle 220 close parentheses raised to the -4th power, I still get a domain error, so it's still not going to like my calculation. Okay, so basically we're stuck doing it manually at that point. Okay, back to number 11. 1 minus j to the 8th. All right, so I can come over here and I can make Pascal's triangle come down to the 8th guy, right? I could do that. Or I could change this to a polar form. So if I'm at 1 and I'm at -1, that's going to be square root of 2 at an angle of -45. So I got square root 2 angle -45 to the 8th power. Okay, so square root of 2 to the 8th power would be 16, and then angle minus 45 times 8 would be minus 360, and that puts you back at 1, so this would be 16 would be my final answer. And let's see if my calculator would do that for me. Well, what mode am I in, I wonder? I'm in rectangular mode. And I want to be in rectangular mode when I get done. 1 parentheses, 1 minus I raised to the 8th power. It won't do it. This stupid machine, anyway. Why did I pay 20 bucks for this thing if it won't even do the problem? But the right answer is 16 there. Okay, so we'll do 13 next. 13 minus 2 square root of 3 minus 2j cubed. All right, well, we could almost do this manually, but we're not gonna. All right, so what is this guy? This guy is a third quadrant guy sitting there, like that. And R is going to be square root of 4 times 3 plus 4 more. 12 plus 4 is 16, so R is equal to 4. And what angle is that? That'd be square root of 3 over 2, so that means the cosine would be at 60. Cosine would be at 30. So this would be a 30-degree angle right there, and half would be on the sine guy. All right, so this is 4 angle 210 cubed. All right, well, if I went and took my calculator and I put it in polar mode, so I'm in polar mode, and I say, okay, what is minus 2 times the square root of 3 minus 2 times I? It would tell me it's 4 angle minus 150. Is 4 angle minus 150 the same as 4 angle 240?
Yeah. Yes. Yeah, 360.
Yeah, it is. Yeah. Okay. So those are the same angles. Okay, so now that I've got in that form, 4 cubed is 64. Angle 3 times 630. 630. Okay, well, I want to convert that to rectangular form. So I could do it many ways. I could go 64 cosine 630 plus j 64 sine 30, right? I could do that, 630. Or I could just take my calculator and put it in a rectangular mode. So now I'm in rectangular mode, and I just put in 64 second function complex angle 630, and I wouldn't even have to go and change the 630 to something else, and I'd end up with minus 64j is what my calculator told me. Now if I took 630 and I subtracted 360 from it, I would get 270, so this would be 24 angle 270, and I don't way to go, 270, and then I'd say, well, yeah, that is minus 64j, because minus 270 is the guy going down this way. Okay, good enough?
That's the whole thing on my calculator.
Yeah, you just put the whole damn thing in your calculator and tells you what the answer is. Yeah. You'd probably do that too. Okay, Guess we'll do 17 next. Number 17. Minus 3 plus 3j raised to the minus 4. Okay, well, minus 3 is there, plus 3 is there. So my angle is going to be what? 135. So I know my angle is 135. And what is the square root of 3 squared plus 3 squared? 9 plus 9 is 18. Square root of 19 is 3 square root of 2. 3 square root of 2 raised to the minus 4th power. All right, well, 3 times the square root of 2 raised to the minus 4th power. 1 divided by answer. Okay, so that's 1 divided by 324 at an angle of 135 times minus 4. So I'm at minus 540. Well, minus 540, I don't like that, do I? Okay, minus 540 plus 360 plus another 360 gives me my 180. All right, so this is 1 over 324th at an angle of 180. So my answer in rectangular form, minus 1 over 324. Okay, good enough. 22. All right, 22. We're running out of problems pretty quick here, so someone's going to have to tell a joke pretty soon. Number 22. I got a very short, it's a one-word joke. You ready? Huh? That's 2 words. I was going to say Ben. One-word joke. All right. Obamacare. All right. All right. So we have to find, we have minus 1, and we want to find all the 6. We want to find all 6 of the roots of the 6 roots of minus 1. All right. So minus 1 is 1 angle 180. Okay. So I raise that to the 1/6 power, and I get 1 angle 30. Okay, so that's the first one. Then I'm going to go and take, I'm going to add 360 to 180. 1 angle 180 plus 360, which puts me back in the same spot. 540 to the 1/6. And I'm going to say that that's 1 angle 90. Okay, and then I'm going to go for the next one. 1 angle, add 360 to that guy. 900. Raise the 1/6. And so that's going to be 1 angle 150. And then I'm going to go 1 angle, add 360 again. And I got 1260. Raise the 1/6, and that's going to be 1 angle 210. And then I'm going to go 1 angle, wow, it does work, plus 360. And I'm going to have 1620 to the 1/6. And that's going to be 1 angle 270. Really? Is it 270? And then we're going to go 1 angle plus another 360. 1980 to the 1/6. And I'm going to get 1 angle 330. And at that point, I'm all the way around the unit circle. My next answer is going to be 1 angle 30. So I'm done. I got 1, 2, 3, 4, 5, 6 answers. And all of those are the 6th root of minus 1. So if I take any of them at random, so I'll take this guy here, 1 angle 210. If I raise it to the 6th power, I'm going to get 1 angle 210 times 6, 1260. It is 210 times 6. All right. Okay, which is 1 angle 180, which is minus 1. So I did that. They just all worked out. Okay. Do 23 next. I got x cubed is equal to 27 angle 405. Well, that's incomplete. 405 is rather incomplete. Okay, well, I'll have to start there anyway. All right, so I want the x's. So x's are going to be 27 angle 405 to the 1/3. All right, so that's going to be 3 angle. What's 1/3 of 405? 405 divided by 3. 130. And then another x would be 27 angle 405 plus 360. 765 to the 1/3. So that's going to be 3 angle 765 divided by 3. 225. 255. And then I'll do it one more time. 27 angle. I'm going to add 360. 765 plus 360. 1125 raised to the 1/3, and that's going to be 3 angle 0. It is? Really? Divided by 3. No, it's not. It's going to be 3 angle 375. Okay, and then we'd say, well, you know, that looks pretty weird, doesn't it? So we'll change this guy to 3 angle 15. And so that'd be the last guy. So 3 angle 15, I add 120 and I get that number. I add 120 and I get this number. I add 120 and I get back to that number. That's an idiot check that I just did that worked. Okay. Looks like 33. Well, we got to do 29. Okay, so we'll do 29 next. 29. X to the 5th is equal to minus 1. So x is going to be minus 1 raised to the 1/5, which is going to be 1 angle 180 raised to the 1/5. 1 angle 180 divided by 5, 36 degrees. So I do the first one. The second one would be 1 angle 180 plus 360, 540 raised to the 1/5. So that'd be 1 angle 108. Okay, now there's a difference between these two, right? You see that right there? See that difference? 108 minus 36. 72 degrees. So the next guy is going to be 72 degrees away. 1 angle 180. 1 angle 262. 272. 252. 252. 1 angle 324. And if I add 72 to 324, 324 plus 72 minus 360, I end up with the 36 I started with. So I don't necessarily have to do all the math sitting there. Once I recognize that this is a circular function, in order to get from the first answer to the second answer, I have to have the same number of degrees between that and the next one. I can simplify the amount of work I do to get the right answer. Because I got 72 degrees there, and I got 72 degrees here, and I got 72 degrees there. Also known as 360 divided by 5. So, not that we want to take shortcuts or anything or get to the right answer any sooner. You know, we want to make sure we show all of our work and give us more of a chance to make a mistake, right? All right, so I've got x cubed is minus 2 plus 11j. Well, isn't that special? So my r is going to be square root 11 squared plus 2 squared. Square root 121 plus 4. Square root of 125. 5 the square root of 5. Okay, so this is 5 square root of 5 at an angle of what? And so I'm here at 2, I'm there at 11, so I want a second quadrant answer. I look at the arctangent of the y guy divided by the x guy in absolute value. Alright, so arctangent 11 divided by 2, 79.695 degrees. Okay, 79.695 degrees. Now, we want the second quadrant answer. This is a reference angle, so we want 180 minus that. So 180 minus the reference angle, and I have 100.3 degrees. Okay, so now I'm ready to start finding my x's. My x is going to be 5 square root of 5, angle 100.3 to the 1/3. Okay, so that's 5, the square root of 5 cubed, right? So that would be the square root of 5. So that'd be square root of 5, angle 100.3 divided by 3, 33.4. 33.4. Okay, and the second guy is going to be 5 square root of 5, angle 460.3 to the 1/3, and that's going to be square root of 5, angle 460.3 divided by 3, 153.4. And the third guy, square root of 5, angle. This doesn't seem to be working very good, does it? There's only going to be 3 of them. does?
Yeah.
I don't think so.
Actually, it's 273.4.
Oh, 273.4. Okay, well that's fine then, because now the next one comes up to there. Okay. So my quick mathematical brain punted on that one. All right, one more problem. See if we can find a good one in the summary, in the review stuff or something. All right, let's do 43 on page 497. So we're going to be on page 497, and we do number 43, and we have x to the fifth is equal to 4 minus j theta. Way to go. Just write the problem wrong. See if I can. All right, so r is going to be square root of 16 plus 16, square root of 32. So that's going to be 4 square root of 2, right? Okay, or it's the square root of 2 to the fifth. So we'll keep it as the square root of 2 to the fifth. That'd be good. Now my angle, I'm at 4 and I'm at minus 4. So my angle's at minus 45 degrees. Okay, so what should we do about that? So we could call this guy x to the fifth is equal to the square root of 2 to the fifth angle minus 45. I think we'll just change that. 360 minus 45. We'll change it to 315 to begin with. And then I won't have any negative numbers and life will be wonderful. Okay. So now I'm looking for the x's. So x is going to be the square root of 2 to the fifth angle 315 to the 1/5. So that'd be square root of 2 angle 63. Gotta be kidding me. 63. And then the square root of 2 to the fifth angle 315 plus 360. 675 to the 1/5. Square root of 2 angle 135. So it looks like we're adding 72, right? So it looks like 72. Notice that the last time we had a fifth guy, we were adding 72 as well. Yeah. Ben claims to think that he remembers that. But that was a long time ago. That was like 5 minutes ago. So the next thing is going to be the square root of 2 plus 72, which would be angle 207. And the next guy is going to be square root of 2, angle 72 more than that, 279. Do I have enough yet? No, and the next guy is going to be square root of 2, add 72, 1 to carry. Is that a 53? And then 72 more than that gets us up to 336. Okay. So we can't see all the answers at the same time, but they're all there. Okay. Isn't that just wonderful? And again, your great-great-great-great-great-grandfathers did not have to worry about imaginary numbers. They had to worry about other things, not imaginary numbers. Yeah, they didn't have to worry about being online. They didn't have to worry about any of those things. So